What's up, YouTube? Today we're going to be looking at the factory pattern. Now, this is not the factory method pattern. This is the factory pattern. If you're looking for the factory method pattern, I have two videos on my channel. One is showing you the code and going into details. The other one is a discussion about the factory method pattern. So you might want to look at those. This one is the factory pattern. So what is exactly the factory pattern besides the coding aspect? First of all, it's different from other patterns in that it doesn't in itself have any polymorphism. Most of the patterns are polymorphic, meaning they use polymorphism to make that pattern work correctly. The factory pattern is not polymorphic. It's a fairly recent pattern, recent meaning probably 10-15 years if that's recent. And it's very, very simple, but it has a very important role, I believe, in enabling polymorphism. So it is not using polymorphism in and of itself, but it enables polymorphism, and I'll explain what I mean by that. So you could have a family of classes. So there's like a base class and there's an n number of descendants, and you have that family. That doesn't make it polymorphism just like that, just because you have a family. What makes it polymorphism is how you use those classes. The trick is to use programming to interface and not implementation. And I discuss all of that in the other video on the factory method pattern. So if you're programming to interface and not implementation, in many ways it implies that the code that is using your family of classes is agnostic of the descendants. It knows of the base class but does not know of any of the descendants, and that is by design. That is the intent or the purpose of polymorphism. In that, now you could say you're using polymorphism. Let's say you decide on a certain condition whether you should create the descendant A or descendant B or descendant C of that same family. And yeah, you could say you're using polymorphism. That's it certainly will work, as in the system will work as expected. And if I were to do the coding correctly, unlike the if-else conditions kind of thing, the behavior will not change. It'll be the same behavior. So you're in some ways getting the benefit of polymorphism. But really, to get the true benefit of polymorphism, you want to be able to treat all classes, all the descendants, all the family of classes in a uniform fashion, which means you shouldn't even know that the descendants exist and what their names are, what their types are. So if you imagine a client code, for example, the client code is the code that uses these classes. It knows of the base class. It's programming to interface. So it knows the base class. It doesn't know the descendants. And if you were to give it an instance of a base class, then it could treat all the descendants in a uniform fashion, because all descendants are effectively an instance of the base class, and so it can program to interface and not implementation. It doesn't know of the actual descendant. It just simply knows the base class and its interface, and all the code writes in that from that point forward. Once it has the instance, it is programming to interface. So to pull that off, to make the code that you write a clean code in the sense you're making true use or getting the true benefit of polymorphism, which is having the ability to treat classes in a uniform fashion, and programming to interface, meaning you're programming only to the base class and not to implementation. By implementation, meaning you don't know about the concrete classes, the descendants. The factory method is going to help you there. Essentially, you're delegating the construction of one or more of these descendants to another class, the factory. This factory is not related to this family of base class, these family of hierarchy, the hierarchy of your family of classes. So it knows of them, but it is not related. So this could be, typically the factory is a static class, it has one method on it called create instance. And that create instance method typically will take some sort of an identifier as an argument. And this identifier is going to help the factory, the create instance method, decide based on that identifier what exactly should it be creating and giving back to the caller. The create instance method signature is always returning the base class of that family, whatever is creating this factory. So let's say you have a family of vehicles, then you would have a vehicle factory. This vehicle factory is not in any shape or form related to the vehicle base or any of the descendants. It knows of the base class, but it doesn't know of specific descendants. So it knows the type, the base vehicle base class. And so the create instance will be creating an instance of a vehicle base using an identifier as an argument that will help the create instance methods implementation decide which one to instantiate and return, meaning you could have, let's say, 10 descendants. This identifier is not necessarily calling out to the exact name of the class. Let's say I've got a Toyota and I've got a Honda and I've got a Mercedes. The identifier doesn't call out directly to say Toyota, Honda, Mercedes. It could, but it's talking more in the terms of the business side of things. So for example, if the business says, hey, I want the set of rules that are applicable to state X, then the state X would be the identifier. What's returning is the rules that apply to that state. So a collection of rules, let's say, that apply to the state the factory is. So you're trying to keep it more business centric than the technical aspect. So you're not necessarily asking for the identifier by the way of the actual name of the type, but maybe there's a close relationship between the identifier and the name of the class, because if you are naming things correctly in your system, then there may be a correlation in terms of the name. But you're not asking for an actual class name, even though that may be the case, where the class name is the same as the identifier that you use in the business, which is quite common or quite possible. This identifier is more at a business level, and you want to keep it that way because you don't want the client side of the code to know the name of the class that you want back. So it's not like the factory is exposing an API that is tying it to the implementation. The identifier is more at a business level, and the create instance will use that identifier to then construct a specific class, a specific descendant of, in this case, vehicle base, and return that instance. So the identifier is simply an identifier. It's not necessarily identifying the class name or whatever. And it could be more than one argument, or a DTO, a value object, a class that has n number of properties associated to it, or part of the class itself. Or it could be an enum or something. Whatever the business side of your application considers an identifier to be. Once the call site, and we are talking about the code of the call site that is supposed to be written correctly, programming to interface and not implementation. Once the call site receives this instance, it's of course treating it as the base class, so vehicle base, and can therefore only use the methods that are available on vehicle base and not any of the other methods that may be available on other descendants. Right? So it's only programming to the interface and not to the implementation. So let's take a look at a sample of a factory method, I'm making the same mistake, the factory. And I've got some code already written out, and I've not got the factory yet. So I've got a family defined. In this case, it's thumbnailers. And so let's take a look at the code. So what I have here is a thumbnailers family, and it's a fairly simple set of classes here. I've got the base class that has a public create thumbnail and then an abstract create thumbnail core. The descendants, in this case thumbnail or image, is simply descending from the thumbnail or base, and it's implementing overriding the thumbnail core And of course, it's not actually doing anything with the image. It's not actually returning anything. It's just writing out to the console. So I have these three descendants: thumbnail or image, thumbnail or audio, and thumbnail or video. And of course, this is the thumbnail or base that their ancestors. So I've got the four classes, the base class, and three descendants. Now on the call side, whoops, I didn't want to actually run it. I don't know why it ran. On the call side here, so let's pretend this is the call side. Over here, I would like to use a factory. So here's how the code, I would like to see the code, and that's typically how I start. If I'm designing something, I'm always looking at it from the perspective of how I would use that code rather than the class, and kind of being in the class while I'm trying to design the API for the class. So this will be thumbnail or base. So I'm going to type the variable as thumbnail or base. And I would like to say thumbnail or factory dot create instance. Now I'll give it some identifier. I don't have an identifier yet, but let's say we used an enum, and the enum had for the moment the three different descendants we have, right? So I'll just define the enum in the same CS file. So I'll call it, let's call it MIME type. So the thumbnailer the enum, sorry, is the MIME type. And it's got image, audio, video, three possible options. All right. So then over here, I would like to give it the MIME type of, let's say, audio, right? And I would expect an instance of something that is a descendant of thumbnail or base that can support, in this case, something to do with audio, thumbnails in this case. And then in my client side, I would simply write the code that says thumbnailer dot create thumbnail, giving it the media file. So for now, I just return the media file would be the actual video file or audio file or photo image, whatever the case, right? The client code is not concerned with the descendants. It doesn't want to know actually the descendants. And that's where the factory comes into play. It does a few things for the client side of the code. One, it abstracts out the construction and sometimes also the decision-making logic for which instance or which descendant to instantiate. So that's the factory's job. If there's some logic involved in determining, a little more complex logic involved in determining whether you should be returning an instance of a thumbnail or image or a thumbnail or video or a thumbnail or audio, the factory will do that. The client code doesn't want to get in the business of deciding which one to instantiate, but it'll provide the factory with some identifier or identifiers so that the factory can then decide how to do that, like which one to instantiate. So now we don't have a thumbnail or factory, so I want to create a thumbnail or factory class. So that's the thumbnail or factory, and this is typically a static class, so I'll make it static. There's really no need to have an instance of it. What are you going to do with multiple instances of this class? Like they're not supposed to maintain state. They'll all behave the same. So what's the point? What's the need for an instance? So I'll make it static. And then the public method will also be static. And it'll return a thumbnail or base. And this is always the case with factory classes that have the create instance method. They should always be returning the base class, right? That's the only way you can pull off polymorphism anyways. And the method is going to be called create instance. And this create instance will take a MIME type enum. And in here, the class will use that MIME type. If there's any n number of arguments, they'll use those arguments to determine which instance to instantiate. So in this case, I'm simply going to use a switch case. And just simply return right, and I'll do the same for all the other implementations. I won't need the breaks here. And for now, I'll just take out the default scenario, default case. Now, this of course is a simple implementation. For now, let's say the default is if you don't specify. Actually, I'll put it as the last one. Not that I'm not trying to make a super resilient system here. I just want to get rid of that error message here. Okay, so this is the simplest form of a factory's implementation. The signature will remain similar. The return type will be similar. The identifier could be anything that will help the factory decide what instance it needs to instantiate. The number of descendants are only known to the factory. Right? So if we add 10 more processors here, you just add them to the factory. The client side, the client code does not need to know what those descendants are, and that's sort of the big purpose of the using a factory here. So it's abstracting or decoupling the client code from the various descendants that are there, as well as the decision-making logic for when you would create that one of those things. And then on the call side, that's it, right? It's done. So now tomorrow, if you added 10 more processors, this code doesn't change. This code doesn't know of those descendants. It doesn't know that you added anything new. It simply works because the factory is deciding if it needs to create one of those new descendants, then it'll just create one of those new descendants and return it here. And the call site is programming to interface and not implementation. So that's the factory. I'm just going to switch back here to the factory class. Now, in real production systems, maybe this logic is quite a bit more extensive. You probably have, like, let's say you got different rules for states. So here in the US, you got 50 states. That logic here could get fairly complicated, but it's not you have to implement it over here. This is still a class. You can still use, good design and refactor this class into separate other classes. But as far as the call side is concerned, it just knows the factory. And so the naming convention would be if you're creating a bunch of thumbnails, then thumbnail or factory. If you're creating a bunch of vehicles, it'll be vehicle factory, and so on and so forth. And everything else, implementation wise, I'll leave that up to you. Signature wise, you should return the base class of whatever it is creating. And the create instance may need 99% of the time, you need some identifier to help the factory decide which instance to instantiate. It could be a setting in a config file that the implementation uses. So based on the setting, the way you define a specific setting in the config file, the factory will instantiate the right type and give that back to you. That is not necessarily the good use case for a factory, because that means it implies that at runtime you only ever create one instance. Whereas the right use of a factory is that at runtime you could programmatically or conditionally decide whether you want to create an instance of thumbnail or image, thumbnail or audio, thumbnail or video, whatever the case is. So it's a runtime decision-making logic that's continuous, meaning it's not just a startup, because you don't need a factory if it's just once, right? But if it's something like this, you're working with, let's say, vehicles, and you have to create engines for different vehicles, and at runtime, so the user or the business or whatever decides you have to create a V6 or a V12 or a V8 engine. That's what the factory will do, right? So I hope this clears up the confusion, or certainly just explains what the factory pattern is about, and that it is different from the factory method pattern, and it is different from the strategy pattern. I made a video earlier that talked about the strategy pattern, and I said that the strategy pattern as described in the book is very much like a factory. So if you look at this thing and you look at the strategy design patterns definition, you'll end up with something like this. Of course, the pattern I proposed in that same video was slightly different. It's another variation of the strategy design pattern, which is not like this, but the one that was described in the book at length is kind of like this. Anyway, use the factory if you have a family of classes that you want, for which you want to abstract the construction of the decision making logic for which you want to instantiate to a separate class like the factory, leaving the call site free of all this logic and decoupling the call site from the possible descendants that you might have in your system, and thus allowing the call site to program to interface and not implementation. I hope you enjoyed this video. Please give me a like, please subscribe, please hit the notify button, and I will see you next time.